Alright, previously in the previous parts we actually derived the PVD from we derived this from the PVD. Alright, and then after that we sub in some stuff, Jacobian and then the strain displacement and things like that. You rewrite in terms of the C domain. Alright, using the shape functions that we have shown you in the previous parts. Alright, this is the shape function in terms of C. Now we're going to show you in terms of the shape functions in terms of X. Okay, in terms of X, and its corresponding shapes are all this. Alright, for N1 is this one, for N2 is this one, things like that. Later we'll at the end of this next video. So this video I'll just convey these things first. Next video I'll just tell you or inform you kindly that these things how it actually relate to this graph. Alright, this is a short one we'll do. So next video we'll talk about it, but the focus over here is just to show you the method of solving. Alright, so therefore let's continue first and we see how. And so previously we actually sub in our strain displacement as this one, right? And then we actually use a chain rule. In this case, because we previously was in terms of a curve C domain, alright, a curve C. So therefore in this domain now we are actually dealing with x1. So we are not actually interested in any of the Jacobian stuff. The Jacobian is simply not our business anymore. Alright, maybe later on we may need the Jacobian, but let's just take note first. Our B is simply this thing over here, and that's it. Alright, and your this thing over here is just simply your shift functions, that this equations. So I'll just simply copy this equation and someone put it here in terms of a kind of like a small scale, because my handwriting just now was very big. But anyway, so you have dx square. This thing is your shape functions. This is our n1, n2, n3, and n4. Okay, so therefore this whole thing over here is your b, right? Is your this b over here. Alright, and I'm gonna dialectic product. Maybe I should write this out over here. And take note that I'm gonna use this integrations also. So I'm gonna rewrite this. Simply bring these conditions up over here first, okay? And then I just simply bring this k over here as L. Alright, you know you're gonna dialectic product with another your transpose over here. So you have the same stuff, b square over dx d1 square. Alright, instead of in this column over here you are writing in terms of the rows. So this, for example, I'll just write this as my A, I'll just call this B, I'll just call this C, I'll call this D. Okay, so this is my shape functions 1, shape functions 2, shape function 3, and shape function 4. I'll just write it as A, B, C, D. So shape function 1 is equals to A, shape function 2 is equals to B. Alright, just for you to take note first. Alright, because I just want to convey the meaning. I just not derive anything. Alright, and then this whole thing is your B transpose over here. Alright, multiply with dx1. Okay, so far so good. Otherwise it's also simply write it as b, b, c, d lah, your shape functions. Okay, so this chunk over here is your b, this thing over here is your d, and then this thing over here is your b transpose dx. You just compare with this. Alright, your b is this one, and then your d is this one, and then your bt is this one, and then your dx1 is this one. Okay, hope that this is pretty clear for you to fully understand stuffs. So I gotta differentiate my a, b, c, and d 2 times. Alright, because it's d2. So I gotta bring them in all together. So I'm gonna differentiate each of the a, b, c, and d 2 times all together. Alright, if yet I didn't actually define to you what is a, b, c, this is your a, b, and c, and d, your shape functions. Alright, so they are correspondingly will be sub it in over here, but I just want, because for the sake of more convenient writing, I'll just do it in this manner. But anyway, so we're going to differentiate 2 times of this. Alright, we're going to differentiate 2 times of this. For example, I will just differentiate n1 first. If I differentiate 2 times, I'll skip the steps. Alright, what you have is, okay, so if I differentiate your a, b, and c, d, what you have is this thing over here. If I differentiate 2 times. Alright, so at this thing over here, I should define that these are all d2 dx square. Okay, if that's the case. Okay, and I can denote them as, this thing over here I can denote as your a prime prime, b prime prime, c prime prime, and d prime prime. Alright, so if I were to write it in terms of this form, okay, I can simply write as a prime prime, b prime prime, c prime prime, d prime prime. Same thing over here. Right, I have this thing. Okay, and then I just simply, because I differentiate already so I have this things over here left over. Okay, next thing I see that this d is a bit gay gao, so I'll just bring this out over here. Alright, so therefore something like this. Okay, it's just some constants. The d is just some constant. I can bring it out, extract it out, factorize it out, or whatsoever that you want to say. Okay, now I'm gonna dyadic product. I take this thing's dyadic with this thing. Alright, so what I have is a prime prime times a prime prime, a prime prime times b prime prime. So I'll take this, multiply by this, take this, multiply by this, and this. So you get what I mean? So I'll just simply rows times column, column times row, sorry. So I have this thing over here. This is a symmetry, because b prime prime, a prime prime is equals to your a prime prime, b prime prime. Because we actually show you, prove, and also prove that this thing over here is the transpose of this thing. Alright, they are the same. This thing over here is the same as this. This is the same as this. So be it b prime prime times a prime prime, or a prime prime times b prime, they are the same, because b prime prime, a b prime prime are the same over here. A and a over here are the same. So therefore, I'll just simply write this in terms of symmetry now. Okay, this is just the understanding. Alright. Now after having all this thing, okay, I'll have an integration of throughout the length of the beam, right? The length of the beam is simply L, and we can start from 0, and we know that it's something like this. At this point, this is 2, this is 1. Okay, I hope that is pretty clear. So therefore, from 0 to length of the bar, alright, in the one direction, x1. Right, so you have some movement in the one direction to some of the extent, if you were to say so. But anyway, so therefore I'll have from 0 to L, okay, dx1. Okay, and therefore, alright, I'll just simply do out this thing. That's just to show you. A prime prime times a prime prime. Alright, what I have is, so of course we know that a prime prime is this thing. So a prime prime times a prime prime, for example, what I have is, so a prime prime times a prime prime is equals to this thing. Okay, so I'll just simply sub in into this thing. I just want to show you okay, I'll just put this in terms of the smaller one, show you better. Alright, so it's just this one, okay, just, alright, better. Alright, so this whole thing over here is a prime prime. Alright, so I'm gonna integrate your 36x over here. Alright, so if I were to integrate this thing, alright, meaning my 36, if I'm gonna integrate this thing over here, alright, from L, alright, my a prime prime over here should be 36 over L4 minus 144x. It's not minus 7.2. That's how it's this one. Now, my careless mistakes. I should have said a prime prime over a prime prime is actually this one. Okay, it's my careless mistake. I'll just simply zoom it in over here. Okay. Now I'm gonna integrate this thing. Alright, gonna integrate this thing because of my, yeah. So if I were to integrate your a prime prime, alright, in terms of dx, I'll have 36x, because 36 now I will have x over here, and then maybe x squared, and then divided by 2, because I think I mean just integration only. Then this is cube, so divided by 3, I have 48. So therefore this thing over here is simply the one I'm writing over here. Can double check. 36x, 72, x squared, and then 48x cubed, things like that. Okay. But anyway, so therefore you will have somewhat proved to you that this thing, when you integrate, is with this thing from 0 to L. You know that when you sub in 0, these are all 0, so you can just simply sub in L will do. Okay. So therefore you have 36L. This is actually 4 sorry. This is L squared now. This is L cubed. So you just simply sub in your x as L. So your x, your L and L cancel, you have L cubed. Your square and this thing cancel, you have L cubed. Your this thing cancel, you have L cubed also. If you were to sum them all together, you have 12 over L cubed. Okay. So therefore, if I were to integrate this thing, all of them, alright, I'll have 12 over L cubed. Alright, if it's A prime prime B prime prime, I will have 6 over L square. Alright, if I were to integrate this one, A prime prime and C prime prime, alright, I'll have 12 over L cubed. Alright, and then so on, so forth. If you fill it up, you have all this. So it's just simply integrating all this to get this thing. Alright, and don't forget you have the D over here. If you still remember, we factorize out the D. Alright, we should also include over the D over here, and this D will also come here. So therefore your K is equals to your D, which is known as EI, alright, multiplied by all these things. Okay, and then if you were to factorize out all your L cube, right, if I were to factorize out my L cube, what I will have is, I should factorize out all my 2 over L cube. Okay, so because maybe I should change back this to D first. So if I have to factorize 2 over L cube, I'll have only 6, right? So 6 is just this value, and then if you have to factorize out 2 over L cube, you will have 3L and things like that. Okay, maybe this is plus, this is minus actually, right? Things like that lah. Okay, at least you get to know what is going on. Alright, so therefore if you factorize 2 over L cube, you will have this thing over here. Alright, this is plus, this is minus. Alright, and I think that's all. Alright, so at least you get to know this is how we derive, and in fact this is something that comes from the last video also. Alright, this is pretty familiar to you. Alright, and therefore this is it. So in the next video, alright, I believe it's the last system of the system, alright, is to elaborate on your shape functions, alright, to give you an understanding of how this is being applied into this graph. You may see this graph, but how, just the intuition and awareness will do. Alright, see you in the next video.